Welcome to Everyday Mathematics. Today, we just like to spend some time making a correction on one of the problems that we attempted to solve. And this was brought to our attention by Art Gechamlati. We appreciate that. And so we've gone ahead to make that correction. The problem in question was the definite integral from x equals to -4 to x equals to +4 of the absolute of the x minus 1 minus 1 absolute value of that minus 1 absolute value of that minus 1 the absolute value of that. So we made some quick assumptions and we provided you a wrong solution, and today we are going to make that correction. Again, sincere apologies from our end, and we are endeavoring to make that correction. So with this problem, as we had indicated in our previous attempt, and really a lot of thanks to our subscriber who brought this to our attention, we would have just continued with that wrong answer. So we'll have to plot this out so that we see what needs to be done. So we have our x-axis and we have our y-axis. And we're going to plot this just within the domain -4 to +4. So we have 0 and we have -1, -2, -3, and -4. And here we have +1, +2, +3, and +4. Now, we begin from the we say when x is equals to -4. So what do we have? We have -4 minus 1 minus 1 minus 1 absolute minus 1 absolute. Okay, so let's see from this part here, we see we have -1, 4 minus 1 is -5. So we have 5, right? And then subtract 1, that goes to +4. Subtract 1, that goes, and then we get obviously the absolute value, we get 3, and then subtract 1, that goes to 2. Okay, so we see that we'll have 1 here and we have 2. So we have 1 there. And we see that this function, this integrand here is linear. So we're just going to be drawing straight line. Now, when x equals to -3, we have -3 minus 1 minus 1 minus 1 minus 1, right? So we're beginning from 4. So from here to here, we have here we're going to 3. To here we're going to 2. And here we're going to 1. And so this is what we have here. What about when x equals to -2? We have -2 minus 1 absolute, -1 absolute, -1 absolute, -1 absolute. You see from here, -1 minus 1 absolute is going to be, we're beginning from 3, and then we go down to 2, we go down to 1 here, and we go down here to 0. So this goes down to 0 here. Okay, so we can just draw a straight line, and this just, yeah, and then when x equals to -1, negative 1 here, have -1 minus 1 absolute, minus 1 absolute, minus 1 absolute, minus 1 absolute. Right? So from here to here, we're beginning from 2, go to 1, go to 0, and then from 0 minus 1 is -1, absolute is going to be +1. So we're going back to 1 here. Okay? And then when x equals to 0, we have 0 minus 1 absolute, minus 1 absolute, minus 1 absolute, minus 1 absolute. So from here to here, 0 minus 1, -1 absolute is +1. We go to 0 here, and then 0 minus 1, we'll go to 1 here, and then 0. So 0, so we are going to 0. And then when x equals to 1, we have 1 minus 1, absolute, minus 1, absolute, minus 1, absolute, minus 1, absolute. So 1 minus 1 is 0. We're beginning from 0, which goes to 1. 1 minus 1, then it goes to 0. Then it goes to -1, +1. So this goes up to 1 here. And we see when x equals to 2, we have 2 minus 1, absolute, minus 1, absolute, minus 1, absolute, minus 1, absolute. So we see we're beginning 2 minus 1, we're beginning from 1. So what we'll do here, we'll see we're going to begin from 1, which goes to 0 afterwards, and then it goes to 1 afterwards, and then to 0. Okay, so this is 0. When x equals to 3, we have 3 minus 1, absolute, minus 1, absolute, minus 1, absolute, minus 1, absolute. So you see here we're beginning from 2, goes to 1, goes to 0, and then goes to 1. So we're having there. Okay? And then when x equals to 4, we have 4 plus 1, absolute, minus 1, absolute, minus 1, absolute, minus 1, absolute. So 4 minus 1 is 3. 3 minus 1 goes to 2. 2 minus 1, we have 1. And then 1 minus 1, we're going to 0. So this goes down to 0 here. We won't bother, but if you are curious, this guy will go up like that from here. So we see we have 3 triangles that have the same kind of dimensions. They have the same dimensions, but we have one that is bigger and it's right angle. So we have 3 isosceles triangles and we have 1 right angle triangle. So integration of a function is the area under a curve. So we're just going to have to solve for the area of this curve. Therefore, -4 to +4, integral of x minus 1, minus 1, absolute, minus 1, absolute, minus 1, absolute, is going to be equal to half. So if this is area 1, 2, 3, 4. So the first triangle is a right angle triangle with the base 2, height 2, right? So base 2 times height 2, and then these other triangles are 3, so we have 3 times a half times the base, which is 2, height, which is 1. Okay, so times 2 base times height. So we see that we have 2 out of here and then 3 out of here. So we have 2 plus 3, which is equals to 5. And that is the answer that was expected, right? And so, so to sum it up, we're saying that the integral from -4 to +4 of the absolute value of x minus 1 absolute minus 1 absolute minus 1 absolute is equals to 5. And that was the answer that was expected. We do apologize for the error we made. And yeah, we'll always correct the mistakes we've made. So until next time, we really thank you and hope you have a good time. If you haven't subscribed to our channel, we do encourage you to subscribe to our channel. Otherwise, bye-bye.